Here's an introduction to how the Freshman Masterpiece radio works. Page 1. Well, anyway, the Freshman Masterpiece radio from circa 1924 is what's called a TRF radio, which is a tuned radio frequency radio. Well, you're probably yelling at your screen now. Well, isn't that any radio? No. If you've watched my other explanation on what a super heterodyne radio is, in short, not every radio works by selecting what frequency they tune to, but that's for another discussion. Anyway, a TRF radio is basically in alignment with this diagram I drew here. Now, it's simple, but yet there are certain things to it that make it so that we don't actually use these anymore. And I'll quit the yapping. Anyway, this is your antenna here. And this is, of course, bringing in all your radio frequencies that are just surrounding us. And the radio frequency goes into the first box here, which has a dial on the front of it. And it has some vacuum tube stuff. These things are vacuum tubes, by the way. The Freshman Masterpiece is a 5-tube radio. It uses a UV201A tube. Excuse me, a UV201A tube. But we'll get there in a second. Anyway, TRF, like I said, is a tuned radio frequency receiver. Now, what these do is each one of these basically amplifies the radio frequency that is coming in through here. But it really has to be tuned, hence these dials, to the specific frequency that you're working with here. And that changes slightly in succession here, which is why there's 3 different dials and not one. So this amplifies a little bit more, a lot of it more, and then finally it goes to a demodulator, which takes the AM signal and turns it into a sound signal, an audio signal, and then finally an audio amplifier to take that small sound signal into a big sound signal and a speaker. That's pretty easy to understand and digest. What is not as easy to understand and digest is this schematic of the Freshman Masterpiece in 1924 radio that, don't ask me how long it took me to draw this. It's because I don't have a printer in my apartment, so I had to just draw this from the diagram. Anyway, this is a complicated looking piece of machinery here until you actually break it down into the sections. This is not that complicated in reality. Now, if I take this diagram back out here, you'll notice there's a lot of similarities here. Antenna, this thing, ground. You have the the current flowing through the circuit this way. You have TRF1 right here, TRF2 right here, TRF3 right here. The demodulator, which is this circuit here, and then the audio amplifier, which is this. And then you have the speaker or headphones, which is right there. And I just noticed, I forgot to make a single connection. So bear with me. This won't actually work until I connect these. Oh man, this is really sloppy. Okay, don't judge me. Anyway, let's take this piece by piece. It's actually, like I said, not that hard to understand. So you have all this ether of radio waves floating around in your atmosphere, and the antenna is what picks it up. Now, unlike in the diagram, the radio waves are a form of like current, for electrical current, and you need somewhere for all that current to go. If you just have an antenna, it's going to be an open circuit. You need a closed circuit. So the radio frequency goes in from the air, into the antenna, down, and out through the ground. And that's basically how the radio frequencies are received. And this is just some tumor that's hanging off the side of it. Now, the way that we actually receive these is the radio frequency passes through this inductor here, L1, inductor 1. Now, this is all part of the first TRF circuit here. L1 is inductively coupled to L1 prime here, and that transfers the signal from the antenna into the first TRF. The TRF1, there are three large knobs in the front of the Freshman Masterpiece radio, and those are your tuning knobs. The first large knob is connected here to CL1, variable capacitor 1. This, if you see here, from my other video on what a tank circuit is, I'll quickly bring that illustration out. Here we are. Tank circuit. It's basically you have an inductor, a capacitor, and current going through. You can have a variable inductor, variable capacitor, or both. In this case, oh, look at that. Inductor, capacitor. It's not a variable inductor, but it's a variable capacitor. And that's what changes the resonant frequency of this tank circuit here. You'll notice there's one here, and there's one here. Oh, look, we'll get there. So this knob here changes the capacitance, which changes the frequency oscillation of this circuit. And this goes to E1, which is the vacuum tube here. The vacuum tubes, all 5 vacuum tubes in the Freshman Masterpiece Radio are identical. They are UV201A tubes, which are triodes, which, if you don't know what that means, basically it's a vacuum tube version of a transistor. So these work in much the same way that a transistor would work in a mid-century circuit. So this goes in here to vacuum tube 1, E1, and oh, the output of that, which is this plate here. You have the heater, the grid, and the plate. Oh no, it goes into another inductor. Look at that. Repeats the exact same thing as TRF1. Happens exactly the same in TRF2. CL2, you guessed it, is the second giant knob on the front of the cabinet. And oh no, the exact same thing happens in TRF3. Would you look at that? CL3, and yep, I know you've assumed by now, that's the third knob on the front of the cabinet. Goes into this last vacuum tube, E3, again, same tube as the other ones. Now, here's where the special stuff happens. Now, you have weak RF signal, getting there. Whoa, now we're there. So the RF signal is now being run down this wire here. You have some capacitive coupling here, you can ignore that for now. And that goes to transformer 1, and there is a core, as you can see, in this transformer, and that couples the radio frequency to the circuit here, E4. E4 is our detector circuit here, detector tube. And that acts as a rectifier. You have a rectifier. This is basically your rectifier circuit here. And that's what turns your radio frequency into audio frequency. And the output of this, you can see, goes to the headphones and to the last circuit, which is your amplifier. Now, why? Mistake here. There we go. Don't judge me. Now, I said in the very poorly done illustration here, if I could find where I put it, here it is. We have an amplifier after the demodulator before we get to the speaker. Well, yeah, I wasn't wrong. I said speaker, not headphones. Headphones, back in the day, looked like this. And these have about 3,000 ohms of impedance. You heard right, 3,000 ohms of impedance. Modern, like, headphones you'd plug in your laptop are about 8 ohms. I'm sure if you're interested in radio, you at one point during your childhood made a crystal radio set, and they certainly came with an earphone like this. And this is along the same operating principle as those headphones. This is a high impedance earphone. And the high impedance, what that means is, with increasing impedance, is also increasing sensitivity. So we can bridge, you can see, we could bridge the signal straight from the demodulator and listen to that through the earphones, the high impedance earphones. That is similar to what it would do in a crystal radio set. Again, there's no amplifier in a crystal radio set, mostly. So we're listening to the pure unamplified signal. So that's what this is doing. But if we want to listen to it through a speaker, again, there are 2 jacks on the front of the Freshman Masterpiece Radio. One is for headphones, and one is for a speaker. The speaker needs an amplified output. So likewise, the audio output of E4, the detector circuit, goes out into T2, the second transformer, which is inductively coupled to the last circuit here. This is your amplifier circuit, and you'll notice it says speaker here, and these are your speaker terminals. E5 is your last tube. Again, that is classic. If you're familiar with a transistor amplifier, that's basically what this does. It's just a vacuum tube version of that. And what do you know? That amplifies it up to speaker amplitude, and we have the speaker output. So phones, speaker, and yeah. There are 2 more controls on the front of the Freshman Masterpiece Radio, and those are 2 potentiometers. Those are here and here. you'll notice there's a fixed resistor in between here. We'll ignore that one for now. But R2 and R3, these are variable resistors. This and this, they go to two knobs that are labeled detector and amplifier. Let me just double check that. Is it what that says? Yep, amplifier and detector, correct. So what those do is, those switch on and off the respective filaments for the vacuum tubes here. You'll notice that the filaments here all go from the A battery. There are two batteries in here. I'll get to that in a second. Don't worry. The A battery here goes to all the heater filaments in the vacuum tubes, and that just keeps them hot so they can operate. And you'll notice if you just trace these all out, oh, whoa, this one's different. This one goes to A minus. Oh, look at that, great. But this one also, oh my God, I am lacking today. Look at that. This one goes to A minus too, but through different variable resistors. And what these do is the amplifier potentiometer here controls the power output of this circuit, the TRF circuitry, and the detector is basically your output. So you have two power controls for your two sides of the circuit, the radio frequency side and the audio side. And then there's a switch here which just turns the thing on and off. That's literally just a power switch. Now, like I said, I will explain the different batteries here. Vacuum tube circuits are a bit different than solid state ones in the fact that they need a solid power for your heater elements so that the actual thermionic emission of the tubes can occur. So you have two batteries here, the A battery and the B battery. The A battery is 6 volts DC. The B battery is 90 volts. Yeah, that's kind of odd for us nowadays. But these batteries were literally called the A battery and the B battery, just like we have nowadays with our cheap garbage Harbor Freight C batteries and our cheap garbage Harbor Freight AA batteries. Same deal, but different ones. Different batteries entirely. If you ever wondered why there's no A or B batteries, well, there are. I digress. The A battery, like you can see here, powers your filaments for all of these. Usually it's around 6.3 volts that vacuum tubes filaments run off of. And the B circuitry here, the B batteries here, power your actual amplification and the actual, junk that happens within the whole amplification and whatever. I'm doing a poor job at phrasing this, but you probably understand what I'm saying. So again, let me just summarize everything that's happening in the circuit. The radio frequencies come from all over, go into your antenna, down through your inductor 1, and out through the ground and dissipate into the earth. As they go through your ground here, not your ground, your inductor, they're inductively coupled to this inductor here, and this is a tank circuit. As you adjust the variable capacitor here, it adjusts the resonant frequency of the circuit, which selects a single frequency, which outputs into this this tube here, the UV201A tube. This amplifies your radio frequency, goes through, inductively couples, same thing twice more. Your last TRF outputs your radio frequency into the next circuit here. This circuit acts as your rectifier, your detector circuit. This changes it from radio frequency into audio frequencies. Your phone hookups, your headphone hookups, are just here because, again, they're high impedance headphones. They don't exactly need a lot of power to drive. And then also connected to your E5 tube here, which is your amplifier tube, your audio amplifier tube. And this circuit amplifies it enough to have a speaker run off of it. Then you have your two variable resistors here to adjust the power of the coils on the vacuum tube heaters on the RF side of the circuit and your audio side of the circuit. And then finally you have the good old-fashioned power switch. So I hope that makes sense. That's how the Freshman Masterpiece radio works, as well as a number of other similar radios, TRF radios. You can recognize them by their age, the 1920s into the early 1930s, before they were replaced by superheterodynes. They're typically low cabinets made of wood, and they have several large knobs on the front with basically arbitrary numbers. And there's, it's not very fancy looking. I mean, some are, but most of them are pretty utilitarian looking. And again, most radios of that type work in this very same way. You just open the top like it's a car, and you could just see the 5 tubes right there. You could see the coils and the variable capacitors. It's right all in front of you, all point to point. It's not a very complex circuit, as you can see. And the final thing I will explain is how you actually operate one of these radios. You obviously start by turning it on, and then you want to put all your variable capacitors, except for one, all the way to their leftmost, their 0 position. You start by tuning this one until it maxes out the frequency for that particular channel you're trying to get. And then you adjust this one, and then adjust this one, and you just kind of play a balancing game throughout the 3 different dials there. And then once you get the specific frequency you want, you write down, literally on a piece of paper. I know, high tech here, it's the 1920s. Well, you write down on a piece of paper the frequency you're at in kilocycles, or nowadays kilohertz. And then literally the 3 numbers on the dials. They're arbitrary numbers, but they're the 3 numbers that you have to put in that combination to achieve that frequency. Again, real high tech, I know, but we're talking about the 1920s here. This is a miracle to many people still, including me. You're getting sound from air, but and yeah, then you plug your headphones in or your speaker, and you have lovely, medium wave AM broadcast music or whatever. But yeah, I hope this helps understand how the Freshman Masterpiece Radio works.